In this session, let us learn about SciPy statistical significance tests. What is a statistical significance test? In statistics, statistical significance means that the result that was produced has a reason behind it. It was not produced randomly or by chance. SciPy provides us with a module called SciPy.stats, which is a function for performing statistical significance tests. Here are some techniques and keywords that are important when performing such tests. Hypothesis in statistics. Hypothesis is an assumption about a parameter in population. Null hypothesis. It assumes that the observation is not statistically significant. Alternate hypothesis. It assumes that the observations are due to some reason. It's alternate to null hypothesis. For example, for an assessment of a student, we would take student is worse than average as a null hypothesis and student is better than average as an alternate hypothesis. One tail test. When our hypothesis is setting for one side of this value only, it is called one tail test. For the null hypothesis, the mean is equal to k, we can have alternate hypothesis. The mean is less than k or the mean is greater than k. Two tail test. When our hypothesis is getting for both sides of the values. For the null hypothesis, the mean is equal to k, we can have alternate hypothesis. The mean is not equal to k, in this case the mean is less than or greater than k and both sides are to be checked. Alpha value. Alpha value is the level of significance. How close to extremes the data must be for null hypothesis to be rejected. It is usually taken as 0.01, 0.05 or 0.1. P-value. P-value tells how close to extreme the data actually is. P-value and alpha values are compared to establish the statistical significance. If p-value is less or equal alpha, we reject the null hypothesis and say that the data is statistical significance, otherwise we accept the null hypothesis. T-test. T-tests are used to determine if there is significant difference between means of two variables and let us know if they belong to the same distribution. It is a two-tailed test. The function t-test underscore ind takes two samples of same size and produces a tuple of a t statistic and p value. See the example. Find the given values v1 and v2 are from same distribution. See, import NumPy as np. From SciPy stats import t-test underscore ind. By importing and executing this, the result returns this. If you want to return only the p-value, use the p-value property. By using p-value property and executing this, the result returns this. K-S test. K-S test is used to check if given values following a distribution. The function takes the value to be tested and the CDF has two parameters. A CDF can be either a string or a callable function that returns the probability. It can be used as a one-tail or two-tail test. By default it is two-tail. We can pass parameter alternative as a string of one of two-sided less or greater. Find the given value follows the normal distribution. By executing this code by using case test v norm, the result returns this. Statistical description of data. In order to see a summary of values in an array, we can use the describe method function. It returns the following description: number of observations knobs, minimum and maximum values is equal to min-max, mean, variance, skewness, kurtosis. Show statistical description of the value in an array. By executing this code, the result returns this. Normally tests skewness and kurtosis. The normal test and function returns a p-value for the null hypothesis. X comes from a normal distribution. Skewness, a measure of symmetry in data. For normal distribution it is 0. If it is negative, it means the data is skewed left. If it is positive, it means the data is skewed right. Kurtosis, a measure of whether the data is heavy or lightly tailed to a normal distribution. A positive kurtosis means heavy tailed. Negative kurtosis means lightly tailed. See the example. Find skewness and kurtosis of values in an array. First you should import skew1 cortices and execute this print skew1 cortices, the result returns this. Okay friends, this is the end of part 9, pandas statistical significance. In next video, let us learn about another topic, Python matplotlib. If you like our program, please like, subscribe and press bell icon for our next part video updates. Thank you friends. Meet you in next video. All the best.